Hey guys, it's Miss Burns. I am out at a math meeting today, so I wanted to go through the notes that we would have gone through in class if I were able to be here. And I wanted to go through these so that you guys wouldn't be left behind and just kind of left to figure all of this out on your own. So what our plan is for today is to finish the notes that we didn't finish last time. We started on one-step equations, and you see on the screen now, we went through this page. I talked about how important equations are, and they're like puzzles, and that sometimes kids who don't necessarily love math really get into equations because it is kind of like being a detective. You're working to solve a missing part and to find a puzzle, and you know, people's brains work differently, and some people really do well with equations. So, and remember, get excited. Okay. Just to review, an equation is different from the expressions unit that we just finished, but because an expression is just this 3 minus 2x part. But when you add an equal sign, that makes something an equation. Remember, equa, or the root word of equations, is equals, and an equation always has to have an equal sign. No matter how far in math that you go, no matter how crazy or complicated these problems get, an equation always has to have an equal sign. So don't drop that equal sign if it's supposed to be in there. We talked about that the word is means equals. And that's very important. We're talking about formulating or writing your own equation. We talked about when we were solving equations, it's so important to have balance. And if you do something to one side of an equation, which remember, an equation, we usually draw a line through the middle at the equal sign, and whatever you might do, let's say we're adding 3 pounds to this side. Well, you've got to go back and add 3 pounds to the other side of an equation, or whatever that you're adding. Whatever you're doing to one side of your equation, do to the other side. All right. We also talked about inverses. The inverse, or the opposite of adding, is subtracting. Those are inverses of each other. We talked about multiplication and division being inverses of each other. We talked about how to solve an equation is to first, number one, you're going to locate the variable in a problem. In this problem, it's an x. But then you need to determine the operation that is going on. Now remember, our operations are just adding, subtracting, multiplying, or dividing. So you need to go back and look at this problem and see what type of problem is this. And you see it is an addition problem. And we go to this side, or to the left side of our problem, because remember, it said locate the variable and see what's happening to the variable. And the variable has something being added to it. So that's so important that you always start your equations by looking to see what kind of operation it is, so that you can go to step 2, which is to determine the inverse of whatever's going on. So to be able to work that puzzle and find that missing number, you need to do the inverse of whatever type problem it is. Well, if we know that it is an addition problem, the inverse would be subtraction. Now remember, when we were talking about, let me go back a screen, when we were talking about our balance scales, our scales have to stay balanced on their equal sign. That's their little reference point. That's their center point. So if I subtracted 1/4 from the left side of my equation, I need to subtract 1/4 from the right side of my equation. To keep everything nice and neat, I always draw a line straight across and see what I need to do now. We know that a positive 1/4 and a negative 1/4 are opposites of each other, and so they equal 0, and so we get rid of them. We cross them out of our problem. And so all that we're left with on the left side of the equation is an x, an equal sign, and then on the right side, we said 10 minus 1/4 is 9 3/4. We also mentioned in class that since you guys would prefer to work decimal numbers instead of fractions a lot of times, you could divide -1 by 4 in your calculator to get 0.25 or minus 0.25. So you could work this as a decimal as well. If you did work it as a decimal, you would get 9.75. These two things are equivalent to each other, so this is our answer. We also made a point of saying that x equals 9/4 is our answer, but we could also write it as 9 3/4 equals x, because these numbers, the number and the variable are swapped, but they still have the same value. That's our commutative property, and as long as you haven't dropped your equal sign, you're fine. We also, our final point was that 9 3/4 x cannot be an answer because you have dropped your equal sign, and now this looks like this 9 3/4 becomes a coefficient to the x, and that's not what we're doing. We are solving to find what x actually is, and that's what we need the equal sign in there for. We talked through this page, and we found that this was a subtraction problem, so we had to do addition to solve it. We separated our equation with our line. We found that subtraction was going on, so we added 5.9. And we're adding 5.9 because this is the thing that's stuck onto the variable on the same side of the equal sign with the variable that we need to get rid of. Our goal is to get that to cross out and to go away. Now remember, whatever you did to your left side of your equation, do exactly the same thing to the right side of the equation. And when you do that, you get x equals 17.9. 17.9 equals x is an alternate answer to that. The next problem we talked through was that what operation is tied to the variable. Here's our variable, and we've got a 1/3 in front of it. Now, we know that fractions mean division, but how is this fraction stuck onto that variable? And you should be saying, well, that's multiplication. Even though it's a fraction, that is the coefficient or the number in front of x, and we know that's an understood multiplication operation going on there. So let me back out and just erase this so I can keep this kind of clean. So if we know that multiplication is going on in our problem, that's the very first thing you ask yourself every time you see an equation. What type of problem is this, and what do I need to do to solve it? And we know that division is the inverse of multiplication, so we're doing the inverse. We're doing this division to, and we're dividing by the same number that we're trying to get rid of. Remember, our first goal is to see if we can cross out something and get that unstuck from x. Draw our line, and then if we divided by 1/3 on the left side, we're dividing by 1/3 on the right side. That way we have gotten rid of our 1/3 away from our x on the left side, so x is all by his lonesome. And by the way, don't be sad for x. That's exactly what he's trying to do. He's trying to free up himself and only be a single old x. That's his goal. Now, this -15 divided by 1/3 is what we need to solve to figure out what x is. Now, just as a reminder, this is a fraction problem. That does not mean you get to skip it just because it looks hard, because guess what? Put -15 over 1, and you've got a keep, change, flip problem where you have -15 over 1 times 3 over 1 if we're following our division rules. Keep, change, flip. That gives us -45 over 1, which simplifies to -45 whole. So if we go back to our problem, x equals -45. Alternate answer would be -45 equals x. All right, let me erase a little bit of the bottom of this problem so that it will not be messy, and so we can see enough of our third example problem. All right, there's a couple of different ways to work this problem. You guys already know how to do this. When we were talking about unit rate, and we had to divide a complex fraction, or we were trying to see if two ratios were proportional, we could cross multiply to solve. Well, let me make your life easy. Cross multiply. All right, so I did 5 times 2 and got 10. Let me move that up just a little bit. Oops. 5 times 2 is 10. And then I put my equal sign. Don't forget your equal sign because this is an equation. And then we did x times 5, and that gives us 5x. Now, at this point, what operation is tied to the variable? So our variable is x, and there's a 5 in front of it. We know that means multiplication is going on. So the inverse of that, to be able to solve it, is division. So I'm not dividing by 10. Just because 10 is on the left side of my equation that's not important. Remember, you're going to the variable side first, which in this case is the right side. Let me draw my line. In this case, it's the right side of my equation, and remember, x wants to be single. He just loves being single, and he wants to be by himself. Perfect. So let's give him what he wants. Divide by 5 on both sides. Your 5's cross out, and you're left with an x on the right side, your equal sign, and when you say 10 divided by 5, you get 2. So 2 equals x, or you could say x equals 2 are our answers. Now, remember, 2x is not an answer choice because you've dropped your equal signs and it's no longer an equation, and you can't do that. That's math illegal. Don't do it. All right, so let's go to I think B3, I think you guys stopped here. I think A3 stopped here, but A4 went a couple of slides more. But either way, this is a good review, so we're going to keep going. One-step equations, solve for the variable. Check your solution. If I'm going too fast, pause the video, go back, listen to it again, and see if you can make sense of what's going on. I'm also trying to watch my time in this video so I do not bore you into a coma for a 3-hour video. That's not my goal. So, okay, we're at 13 minutes. Okay, we got this. All right, let's choose some Ole Miss Rebel Blue to do this next problem. You're welcome. All right, let's look. We've got 0.85 equals A over negative 7.2. It doesn't matter that these are decimals and fractions and whatever. Go find where your variable is. Whoops. Go find where your variable is and see what operation is tied to the variable. Now, there's a couple of different ways to do this. Let me show you this way, because you already know how to solve this. What would you do now? Cross multiply? You're right. Y'all are so smart. Somebody must have taught y'all really well about cross multiplying. All right, so at this point, we say 0.85 times negative 7.2, and you get negative 6.12. And if you say A times 1, you get 1A. Now, 1A and A are the same thing, so my final answer is A equals negative 6.12, or negative 6 1200ths. Negative 6.12 equals A is an alternate answer. If we go back and look at our original question about which operation is tied to the variable, the way that we worked it, we did cross multiplication. If ever you can make those into fractions and work it out that way, you guys already know that. It's not even something new that you have to crowd up and clog up your brain learning something new. That's how you do that. The inverse would be division, which the division would actually come in right here, but we know that 1a and 1a divided by 1 on both sides gives us the same thing. That's how we got there. So we actually did that division in our heads. I didn't even take too much time going through that because that is something you guys have been doing for a little while. Rebel Red, switch to for the next problem? I sure will. Okay, so let's look at this problem. -5/9 m equals 1 11/12. All right, so can't really do that cross multiplying trick on this one, but let's just go through it. The operation tied to the variable. This -5/9 is stuck onto the m how? Do not say subtraction. That is a -5/9 that is stuck onto the m through multiplication because this -5/9, remember, is just your coefficient. And coefficients stick onto that variable by the way of multiplication. So we know that multiplication is going on, so the inverse is division. I'm going to draw a line through my equal sign just to keep my two sides separate and neat. I'm dividing by 5/9 or -5/9. Well, if you don't divide by -5/9, then you're still going to have this negative left after you cross out your 5/9, and we don't need that negativity. We need to divide by the negative and that 5/9. So we're dividing by -5/9 on both sides. All right, we're going to cross out our -5/9 because we've not only crossed out the fraction, but we now have also made sure that we're canceling out that negative sign as well. So all that we have left is an m, and our equal sign is just brought down. Now, we need to just go over to the side and work this problem. So as a fraction, 1 11/12 is the same as 23/12. And we're dividing by -5/9. We do our division of fractions rule, which is keep, change, flip. So we're keeping 23/12. We've changed the division into multiplication, and we have flipped the -5/9 to -9/5. All right, let me look at the notes because I'm not going to do that in my head that quick because I don't want to make any mistakes. So when you multiply that, you get -207/60. You can leave it like an improper fraction at this point, or if you want to divide it out and get a mixed number, it would be -3 and 9/20. Or if you wanted to work all of this as a decimal, it would be -3 and, let me do this in my head real quick, -3.45. Okay? So all of these are possible answer choices for that. Pick one and go with it. I will always have all of these answer choices on my answer key when we're dealing with these complex type fractions. So as long as you know how to work one of those, that's fine. All right, let me erase a little bit of the bottom so we can see our problem. And I guess we'll go back to some blue just so I can bring y'all some red and blue happiness in your life. You're welcome. All right, -2.25 plus p equals -0.59. All right, so if we look at the operation tied to the variable, we're looking at the fact that this is a plus or an addition problem. However, if you think about it, when we do all of these problems, remember I told you that the variable wants to be by himself or herself. I don't know what a variable is. I don't know if it's a girl or boy. We'll just say it's a boy right now. The variable p wants to be by himself. So what is stuck onto that? Well, this -2.25 is stuck onto that. Now remember, the only way we can do anything to cross that out is to do the opposite or the inverse of this because we're trying to get it to 0. So what is the opposite of a negative 2.25? It is a positive 2.25. So on the left side of our equation, in order to get p, the variable p by itself, we had to add 2.25. Seems like a crazy thing to do. Maybe it's the equation's looking a little backwards than normal. That's fine. Just follow your steps. You don't have to understand every single part of this now. Just follow your steps. Now, you have this negative and this positive 2.25 that have crossed each other out, and we are left with the variable p. We know our equal sign is always in the middle of our problem, through that line in the middle, and then we say negative 0.59 plus 2.25, and we get 1.66, and that is our answer. 1.66 equals p is an alternate answer, just to throw that out there, because I want you to get in the habit of knowing that you can write this either way and it's still correct as long as you still have that equal sign in your problem. All right, Amanda's work and solution to the equation is shown below. Is she correct? If not, correct her work. Okay. Negative 4k equals 20. That's our problem right here. Is she correct? If not, correct her work. Now, there's a couple of ways you can work problems like this when it tells you to find the error. I always say, well, I know how to solve an equation. What's so hard about that? Let me just go over here and I'm going to write it and I'm going to work it without even looking at her stuff. I don't even want to look at Amanda's work right now. I know how to do this. My math teacher loves equations so much that it just wore off on me, and I got this. So I would go over and say, I'm going to draw a line through the middle, and I know that negative 4 and a k, that means that's a multiplication problem. So I need to do division to solve it. So I'm going to go over here. Ooh, that looks funny, Miss Burns, but I'm going to trust you because you love math and you love equations. I'm just going to trust you. Now, I'm dividing by negative 4 on both sides. I'm dividing by that because that's the thing that is stuck onto that k, and that's the thing that we need to get rid of. Not just the 4, but the negative have gone away. They've crossed out, and I'm left with a k. Equals 20 divided by negative 4 is negative 5. So that's the correct answer. And if we went back and plugged negative 5 into our equation, let's do that. We haven't checked any today. Bad teacher, bad teacher. Let's go back and check this. Negative 4k equals 20. Here's how you check it. You would say negative 4, and then you're going to put your answer in right here. You're going to substitute that in for k, because look, k, you're telling me k is equal to this, so I should be able to plug this in right here, and it better be able to give me the answer of 20, or I've done something wrong. So you have a negative 4 times a negative 5. A negative and a negative make a positive, and then 4 times 5 is 20. That indeed is our answer, and that's how you have just checked your work. Every equation, no matter how simple or complex, can always be checked by taking your answer and substituting it back into the original problem and working it out. And if you get that both sides equal each other at the very end, then your answer is correct. So in theory, you should be able to know that you made 100 on a test because you've checked everything, plugged it back in, and if both sides are equal, then you should be right. Now, if they're not equal, you need to go back and look at it again and something's wrong somewhere. So in this problem, let me switch to purple for just a second. If we compare our work of dividing a negative 4 and we look at Amanda's work where she added 4, that's the problem. Amanda should not have added 4. What Amanda thought was she saw this negative 4 in front of k, and she said, oh, guess that must be subtraction. No, Miss Amanda, that's not right. Because we know any time we have a variable with a number right in front of it and there is no sign in between the number 4 and k, that means multiplication is happening. And if we know multiplication is happening, then we do division to solve our answer, to solve our equation. All right, let me do a time check. All right, we're at 25 minutes. Okay, rocking along. The next one, Ron's work and solution to the equation -16 equals -1 plus m is shown below. Is he correct? If not, correct his work. Now remember, I told y'all, have confidence in yourselves. Go over to the side and work this problem on your own and then go back and compare it to Ryan and see where he went wrong. So we separated our two sides of the equation and find our variable. We know that an addition problem is going on, but remember, this -1 is what we're trying to get rid of. And I need to do the inverse of whatever this is. The -1, to be able to cancel it out and get it away from this side and get it away from that m, I need to do adding 1. I need to say +1. And whatever I've done to my right side of my equation now, I'm going to the left side and doing exactly the same thing. Draw a line across because it keeps things so clear and clean, and it helps you guys stay organized so that you see very easily that you're going to cross out your -1 and your +1 because they just equal 0. So that's why we're able to cross it out. We're only left with an m on the right side. We brought down our equal sign, and over here we've got -16 plus 1. Do not say 17 on that. Do not say 15 because it is a -16 plus 1. And this is an easy calculator problem. And you should get -15 equals m. The alternate answer would be m equals what? -15. Good. All right. Ooh, now we're going into talking about creating our own equations. Now, I will be honest with you. This is the harder part of the equations notes today. Okay? That doesn't mean it's impossible, and you've gotten some background information and background knowledge this year that you can build on to take this to writing your own equations. You have to remember those math keywords that we talked about last unit, and in that way, we're going to build on that and be able to create our own 1- and 2-step equations. So the word problems call on your practical everyday knowledge of the world and also your ability to recognize those math keywords that represent math operations. Okay, so if remember on the back side of the orange Unit 4 vocab sheet that I gave you, on the back side of it were the keywords. If you're still having problems with that, then you need to go back and learn those. They are not going away. I'm not trying to be ugly. I'm trying to help you because that will make your life easy. The fact that of means multiplication is something that you're going to see a ton of. Is, I can't stress it enough, means equals. 2 plus 2 is 4, equals. You just got to be able to read a sentence and pull out that information. So if we're talking about some three quick key questions you must ask yourself with every word problem. Number 1, what information has been given? All right, so what information has been given already? And what operations are being used? The second important question you should ask yourself is there a total or a final amount that has been given? Sometimes there is, sometimes there isn't. We don't know. It's different with every problem. So if you can find a total or a final, that's an important bit of information as a clue on how to write this as an equation. Number 3, what information is missing? What does the variable represent? What are we trying to find? What is the unknown? So, given information, total and final amount information, and the part that is missing. Those are the three keys the three key points that I want to share with you so that you'll be able to write your own equation. There's not one kind of formula I can give you for writing this. Like, you really just have to dig in and see, what is this problem asking? In your equation, you're trying to tell the story how it happened. You're not trying to reinvent information to make it work for your problem. You're just going by what the problem is telling you. All right, so let's do a few and just kind of get warmed up on these. It says, write the word sentence as an equation. Okay, so we're just turning these words into an equation. Number 1 says 4 less than a number n is negative 15. Okay, so let's think about what are some of these keywords in here. We've got the number 4 less than, lasso. A number n is negative 15. Now, just like we wrote expressions and we went left to right order, just like a sentence is read, that's how we're going to write an equation. Now remember, just like in expressions, the only time we're not going from left to right is when we see the word than and from. Let's see, than and from. Those are lasso or switch words. Janorian in my A4 block calls them scoop words because you got to scoop them up and move them over. So than and from are our switch words. So let's just start going with this. All right, 4 less than. Now, I think I'm going to write this in left to right order, and then at the very end I'm going to go back and switch it. I'll show you another way. If you have a different way, you'll do it. So 4 less than a number n, so n, is means equals negative 15. Now, that means we're about to switch some things. So when I lasso it, I'm going to swap these two things, so it would actually be n minus 4 equals negative 15. Now, in these examples that we're doing, all we're doing right now is writing the equation. We're not going to solve these yet. You could solve this. You have the tools in your brain already to solve this. You would see what kind of problem it is. It's subtraction, so that means you're going to do addition to solve. But in the interest of time, I'm only showing you how to write these or to formulate these expressions right now, or equations, not expressions. Number 2, 1/2 of the sum of 3 and x is 15. Okay, so 1/2 is just 1 over 2. Of means times, and we're multiplying 1/2 times this whole thing, the sum of 3 and x. If you're summing something, that means you've got two parts involved, and that's a 3 and an x that you're about to sum. So that means we're putting those in parentheses. 3 sum x is means equals, and then 15. So you see, we just created a distributive property equation, which you don't quite know how to do that, but maybe. You have enough tools in your brain that, you know, if your life depended on it, you could do it. If I wanted to rewrite this best way mathematically, I would say 1/2 3 plus x equals 15. Yikes. Thanks. This sign right there, that multiplication sign, does not have to be there. It's not wrong. It's just this is the best way to write that equation, where you don't have that multiplication sign in between the number and the parentheses. because you should be able to recognize that that's distributive property, and that's an understood that you're gonna, if we wanted to work this out, we would say 1/2 times that, and 1/2 times that, and then work it out. We're not quite doing that quite yet. All right, 3 fewer than 1/4 of x is 12. All right, I'm going to work this. Instead of working it left to right like I did for number 1 and then going back and lassoing it, I'm going to lasso it from the beginning. The reason I'm lassoing is that word right there. So we're going to have 3 fewer than something. What is 3 fewer than? Well, 3 fewer than this. 1/4 of means times x. Now remember, 1/4 x is the same as 1/4 of x, or 1/4 times x. Same thing. Is 12. That is your equation right there. Let's go back to green. The quotient means you're about to divide, and we're about to divide a number and -1.5. So there's a couple of ways that we write division in equations. Either one is perfectly fine. So we could say, let's just use n for our variable, divided by, let me make that a little bigger, n divided by -1.5. A lot of times you'll see that this -1.5 is going to be in parentheses, just so it holds that negative in with it and it doesn't kind of get mixed up and lost with this division symbol. So we've got a number divided by -1.5 is 21. That's absolutely fine to write it like that, but I want you to also be aware that, remember, quotient means division. Division can look like a fraction. So it could look like this, n divided by -1.5 in fraction form is 21. And we saw that in an example a couple of slides ago where we could put this 21 over 1 and we could cross multiply and make our life easy. That's how that problem comes about right there. All right, number 5. 19 is the product of a number and 5 minus 6. Okay, we got this. Left to right. 19 is the product of, okay, product means something's about to happen, a number and 5 minus 6. But product means we're about to multiply two things. And what two things are we multiplying? A number and 5. We're going to clean that up in a little bit, but let's just get down our information first. So we have a product of number and 5 minus 6. Okay? Clean it up a little bit, and we know how to make this a little more middle school and not so 6th grade. We got this. 19 equals a number times 5. N times 5 is just 5n. And then we bring that minus 6 down. Now, but Miss Burns, the variable n is on the other side of the equal sign, and that just looks funny. That's fine. That means you're growing up and you are learning things that are way more advanced than you've learned in the past, and you're just going to get used to that. The variable can be on either side of your equal sign, and that's just fine. Don't let that stress you out. We don't get stressed in equations. Miss Burns is too happy about it. Oh, so much energy. I need a Gatorade. All right, example 1. Write a two-step equation to represent a situation. Okay? It says, Cole buys a new laptop for $335. He makes a down payment of $50 and pays the rest in 6 equal monthly payments. And we're going to use P for the monthly payments. What equation represents the relationship between the cost of the laptop and Cole's payments? Okay, at the very beginning of the problem, it gives us our first bit of information that's important. All right, forget that this is Cole. Just think about if this is you. If you go to Best Buy and you buy a new laptop, I don't know how you're going to do it, but You're going to just pay $335 for it. Congratulations. That's a really good deal. So when it's asking us the cost of the laptop, we know that that is $335. I'm going to do it in a little darker color so it stands out. That's $335. Now, he makes a down payment of $50. So down here, I'm going to fill in that blank that he's making a down payment of $50. But the rest of what he owes is going to be in 6 equal monthly payments. And we're representing that with the variable P. All right, so if you'll see, 1, 2, 3, 4, 5, 6 different monthly payments plus that $50 is going to equal $335. Okay, do you see this breakdown? This whole amount of $335, which is the whole cost of the laptop, is going to be made up of whatever he made a down payment of, plus this monthly payment, and this one, and this one, and this, and this, and this. Okay? So, let's write that in equation form. Notice the 335 and then this 50 and all these different P for the monthly payments, all of those are equal to each other. So if I say $50 for the down payment plus P plus P plus P, I'm going to do that 6 times, remember? Because there's 6 monthly payments. We know that that is going to equal the total amount of that laptop, and that's how much he needs to pay for it to be totally his and that he doesn't have to owe anything on. All right, so what this looks like, remember, you can do this from this point. You know how to clean this up. When you see a variable and there's not a coefficient, there is an understood 1 in front of it, in front of all of these. And if I combine all of these like terms, which we just finished having a unit on, if I wanted to clean that up, that would look like this. 50 plus 6P, because remember, 1, 2, 3, 4, 5, 6. 6P, and that's going to be equal to $335. Now, you could have said, all right, well, to make up the $335, I'm going to have the $50 plus the 6 payments. You could have written it backwards because look at these two things. You see that those are saying the same thing, we just have them swapped on different sides of the equal sign in each equation. But notice, just like we can have, like, let's just say we had x equal 5. That's the same as 5 equals x. The theory is the same. You can swap things on each side of the equal sign, but whatever all of this is, all of this, if you wanted to put it on the other side of the equal sign, all of that together has to go. You can't take one thing and move it over because then we become unbalanced. But anyway, if that doesn't make sense to you, the important part is creating this equation. All right, let's do another example. Wake up! I got some of y'all, didn't I? All right, example 2. Write more two-step equations. Sally Mae deposited $25 into her savings account every week. She sees a cute pair of shoes and buys them for $125. If she currently has $575 in her savings account, write an equation to show the relationship between the number of weeks W she's been saving and her current savings account. All right, so we have a weekly deposit that Sally Mae does. And it tells us that right here. And then we need to subtract her shoes amount. And that's going to give us her total of what she has in her savings account now. Her current savings account. All right, so let's see. Do we know her total? And I'm kind of just working around. I guess let me just go in order so I don't confuse anybody. All right, she deposited $25 into her account every week. She sees a cute pair of shoes and buys them for $125. All right, so 2W minus 125 equals 575. Okay. So let's work this problem. What type of problem is it? Oh, wait, we're not working this yet. My bad. We're just going to stop right here. See how much I get excited about equations? That's as much as we need to do right now. We're just going to write the equation. We're not going to solve it yet. All right, going forward. Jim works at a factory for $18 an hour. After receiving a $212 bonus check, Jim takes home a paycheck for $320. Write an equation to show the relationship between the number of hours, H, Jim has worked, and his paycheck. All right. Let's see. Let's talk about how we get to a total. Remember, if we can find any given information and then missing information and then total, that's important things to know. If I back up to this slide right here, remember the 3 questions you should ask yourself. See if there's anything given, see if there's a total given, and see what's missing. Okay? So let's talk about what is given. All right, so we have $18 an hour. How many hours? Do we know? How many hours does Jim work? Maybe 1, maybe 1,000. We have no idea. That's our missing information right there. Okay, if they're telling us that we're using the variable H, they're telling us what we're looking for. They're telling us we're looking for something that has to do with hours. Now, if you go back to this problem and it gives us $18 an hour, that means 18 for each hour, or 18 times every hour, or just 18H. Okay. After receiving a $200 bonus check. Now, if you're receiving a bonus check, that is being given to you. That is an information that is given to you, and we only get that one time, so it doesn't need a variable with it. So the given information of the bonus check plus the number of hours that he works is going to give us his total paycheck amount. Okay? So what is his total paycheck amount? Does it tell us that? Sure does. His paycheck is $320. Now we have found our given information, our missing information, and our total. Now it's not going to always be given to you in a problem in that order. You might have to, it might give you the missing information, then the given information, then the total. Or it might give you the total and then the missing, then the given. It doesn't matter. You just need to know that these are 3 different things in a word problem that you're looking for. A given, a missing, and a total. It might not have to deal with money, but those are the 3 things, as much as I can, that can kind of create a little bit of an equation type formula in your head. Because there's not one way you can work, there's not one way I can tell you to be able to write an equation. But that's the most information I can kind of give you, because you kind of have to use some common sense with this. All right, let's do some more. Formulating / writing equations. All right, you're going to order some jeans online from Belk. The jeans cost $54.79 each. You also have to pay a one-time shipping fee of $7. If you have $231 to spend, write an equation to show how many pairs of jeans, J, you can order. So right here, this is important information. When it gives us a variable, remember that's telling us what is missing. That is telling us the thing that we're trying to figure out. The variable is the puzzle we're trying to solve. It's the answer we're trying to find. So when they give you this information, that's a huge clue as to what you need to be thinking. So we're trying to figure out how many pairs of jeans you can order. All right, so let's just go in order of the problem this time. The jeans cost $54.79 each. Here's what I'm going to tell you. When you see this word each in a word problem, hallelujah for you, because that makes your life a lot easier, because you know that that's where you're going to need a variable. Almost always. Now, I don't want to say 100% of the time, but for our purposes, when you see the word each, and sometimes you might see the word per, like per day or per hour or per person. Those are huge clue words to you that most likely you're going to put a variable with whatever your each word goes with. Here's what that means. Let me switch over to blue so you can see it a little better. You're talking about 54.79 each. That's where your variable is going to go, and they've already told us that we want to use the variable J. All right, so 54.79 J. Then we're going to go in our problem a one-time shipping fee of $7. Now, I know we talked about the word of means times, but remember, think about what you're talking about in this problem. When you order something online, you pay for the product, and a lot of times you have to add a shipping cost or a shipping fee on top of that. So we're adding a $7 fee on top of the actual cost of the jeans to equal our total amount. Now, our total that we can spend is $231. We can't go any higher than that. And this is our equation. And that's as far as you can go. Because remember, all we're doing is writing these right now. We are not solving these. All right, next. Anthony ate half a bag of candy, then gave away 7 pieces to his friend David. His bag of candy now has 5 pieces left. Write an equation to find out how many pieces of candy C that he started with. Remember, we're going to try in this problem to find out how much candy that he started with. In the interest of being a nice teacher, did you see where I just clicked on this maroon? Hurts my eyes a little bit, but I'll show y'all some love. All right, so let's talk about the problem. Anthony ate half a bag of candy. Half of his candy he ate. And then he gave away 7 pieces. You're giving away 7 pieces. He now has 5 pieces left. That's his total after he gave some away and he ate some. That is Anthony's equation to find out how much candy he started with. Okay. All right, a quadrilateral has sides of 9x, 2x, 3, and 4 inches. Remember, anytime you ever see the word quad, that means 4. Just in life, that means 4. Quadrilateral, just quad means 4. Okay, if the perimeter of the quadrilateral is 40 inches, write an equation to find the value of x. Perimeter. Look how I just drew that quadrilateral. Some of y'all might have drawn a square. That's fine. It might be a square. Who knows? I just know that one side is 9x. I know that one side is 2x. I know that one side is 3. And I know that another side is 4. All I know is that it is a 4-sided figure, and I know that because it said quadrilateral. And it only gave me 4 measurements for the side. Perimeter. Perimeter means the outside of a figure. That is so very important that you know that. That it should just be secondhand knowledge, that as soon as you snap your fingers, you'll know perimeter just means to add up all the sides, and that's how you find the perimeter. Well, the perimeter, it actually tells us, is 40. So right here, we don't have to be finding the perimeter. It's actually telling us that it's 40. So I'm going to erase this P because I actually know that it's 40. So I'm putting that in the place of P because it tells us that in the problem right here. So here is our equation. Now, you could clean it up a little bit and you could combine your like terms. Either way, I want you to write it like this first, and then you could go back and say, well, 40 is going to be, if you combine these like terms, it's going to be 11x. If you combine these like terms, it's 7. So this is the fully simplified version of the equation for this problem. 40 equals 11x plus 7. All right. Next, which scenario represents the equation 5n minus 3 equals 42? All right, so you kind of, in these type problems, you really just have to read through the different answer choices and see if it makes sense. You know that if it's a subtraction problem like this, maybe you're taking away or you're being charged extra. Well, let's just see what the problem is. All right, again, just like we worked a problem earlier and we were trying to find the error in Amanda and I think it was Ron or somebody's, we were trying to find their error. That's what we're doing. We can kind of set up these problems on our own and then go back and look and see if it matches this equation that's given to us. We could do it either way. All right, so, well, let's do this. If pizzas cost $5 each, what variable are we using? All right, it tells us, maybe we'll just use an n here. I don't know. And there is a delivery charge of $3. So the number of pizzas, or the cost of the pizzas, plus the delivery equals our total, which is 42. Is that what the problem is asking us? No, because this right here makes this not a correct answer choice. So number 1, no. All right, let's look at number 2. Pizzas cost $3 each. Remember, if you see that each word, that's where your variable is going to go. So 3n, and you have a $5 coupon. Now, our coupon takes off money from your total. So we're subtracting 5, and then it is 42, so equals 42. Is that what that problem is asking us? No, because these two numbers are swapped, and that's not correct. All right, let's look at 3. Pizzas cost $3 each, so 3n. And there's a delivery charge, so that's our pizza number, and then we're adding $5 to it, and our total bill is $42. Is that correct? No. Not only are the numbers switched, this was an addition problem, and that is not what the original problem asked us. So hopefully we know that answer choice 4 is going to be our answer, but let's work through it. Pizzas cost $5 each means put a variable with this number. All right, you have a $3 coupon. Remember, coupons subtract from your total amount. Or we're taking away $3. And then your total bill is $42. And that is, in fact, what the original problem gave us. So that is the correct scenario for the equation given at the very beginning. Okay? All right, so let's combine everything we've done so far. And now we're not going to only write the equation, but we're also going to solve the equation. We can do this. I promise. Promise. We got this. All right, Andrew filled a bucket with water. When he went to retrieve the bucket a few hours later, he realized it had a small hole and 3.8 gallons of water had leaked out of the bucket. That's a bummer. The bucket now only has 2.9 gallons. How much water was originally in the bucket? Okay, so he had a bucket. He set it aside and went back. It had water leak out of it. Now now it only has 2.9 gallons. But we want to know how much water was in it originally. Okay. So when we started at the beginning, or when Andrew started his life with a bucket for this problem, that bucket had a certain amount of water in it. And we don't know how much water. I mean, that's what we're looking for. How much water was in it originally? We don't know. So we're just putting a W there. That's our unknown. That's our missing amount. We have no clue what that is. But we do know that whatever this was, his starting water amount, he had some leak out, which means there were some that subtracted out. And how much? Well, it tells us 3.8 gallons of water had leaked out. So we're subtracting that from our starting point, which was W. At the very end, once the water subtracted out this amount, then there was 2.9 gallons left. All right, so we have just created our one-step equation, and we have W minus 3.8 equals 2.9. So that is our equation for this problem. All right, now let's solve this. We're going to draw a line through our equal sign just so we can keep our two sides of our equations very equal and balanced. And it reminds you, this line, by doing this, it reminds you to stay balanced. All right, now remember, when you're solving a one-step equation, you have to ask yourself, what operation is going on right now? Well, we've got subtraction. So in order to solve it, to be good little detectives, we need to use the inverse, which is addition. So that means we need to add 3.8 to the left side in order for that to cancel out, because those are opposites of each other, and that just equals 0. So we added 3.8. We want balance and harmony in our lives. Who doesn't? So we're left with W equals, let's add that up on your handy dandy calculators, and you should get W equals 6.7. What does that mean? Think about what we just solved. You might be rocking through these equations and you know exactly what to do, but go back and tell me, what does this mean? Well, I know it means W equals 6.7, but that's how much water. Remember, what were we trying to find by solving for this variable? How much water was in the bucket originally, before Andrew had any kind of leaking problems in his life. He started out with 6.7 gallons. That's what that means. All right, I'm doing a time check on myself because I'm not trying to kill y'all today. We're at a little over an hour. All right. Write the equation, solve, and check your solution. Mrs. Sanders had a balance of, pause. What does that mean? MS period. Means miss or Mrs. When do you write that? when it's a single lady, or it is maybe somebody who's unmarried, which does mean single. It can be if you don't know. A lot of times I'll leave a note for a sub and maybe I don't know them, and I always want to show respect by showing your salutation at the beginning. So I always write, if I don't know, I always write Miss. Okay. All right, Miss Sanders had a balance of $405.87 in her savings account. She deposited D dollars, and her new balance was $552.25. How much money was deposited? Sorry. All right, so where did we start? We started with her 405.87 balance. If you deposit money, if Mrs. Sanders deposits money, she is adding to her account. How much? Zero clue right now until we figure it out. But she adds a certain deposit, and I'm using D because it told us. Use the variable D. After her original amount plus her deposit, she now has a total of $552.25. And you got this answer. All right, we've got our line through the middle, separating our two sides of the equation. Now, we know that this is an addition problem. However, I want you to look, especially since this constant, why is that a constant, V3, A3, or A4? Because it is a number that does not have a variable with it. So this constant right here, it's an understood positive. Any number that doesn't have a sign, remember, is an understood positive. So if we are trying to get rid of this, so D can be by itself, all by its lonesome self on that side of our equation, we need to subtract that away. Whatever I have done to one side of my equation, go do to the other, or the algebra gods will hunt you down. I know, they're rough, aren't they? They're rough. They only have to hunt you down once, maybe twice. All right, let's see what we have left. The 405.87s cross out because these are opposites of each other, which means they just cancel out because they're at 0. And we have a D. Well, technically we have a plus D left over here, but that's the same thing as a positive D or just D equals, use your calculator for this, and you get 142.38. What does that represent? What does that represent? That represents the amount of her deposit that she made. That's how much money she put into her account. Why might she put such a weird number in her account? Maybe she was paid a check for working and it was this weird number. I've had kids say, well, why didn't she just put $142 in? Well, maybe it was just a check and that was what the check was written for. Like somebody gave her a check and she put it in the bank and it was for that amount. Or maybe, she just took a percent of her paycheck and put it in her savings account. There's lots of reasons for why this would be such a weird number, but just real world, I wanted to point that out to you guys. Let's look at number 2. The temperature was X degrees Fahrenheit. The temperature dropped 14 degrees. The new temperature was negative 35 degrees. What was the original temperature? All right, let's just start at the beginning of our problem. The temperature was X degrees. I have no idea what that is yet, but I do know that whatever this X temperature was, it dropped or subtracted it took away 14 degrees from it. It went lower, subtracted. And when that happened, the new temperature was negative 35 degrees. Brr. What was the original temperature? All right, let's do it. Draw your line down your equal sign to separate your two sides. Look at your problem. You've got a subtraction problem going on, so we need to do the inverse, which is addition, or we're adding 14 to both sides. That gives us the ability to cross this out and have nothing on the left side except the x. We still have our equal sign. Don't ever forget your equal sign. It's so important. And then on the right side, we have negative 35 plus 14. Do it on your calculator or else. And that gives you negative 21. That's not the answer because x equals negative 21 is your answer. So that means the original temperature, where we started the day, was negative 21 degrees. Yikes. But then, as if that wasn't cold enough, it went and dropped. And that's how we got to negative 35. Don't know where that is, but that seems really cold. Maybe it's one of those places where they have those ice hotels. If you don't know what I'm talking about when I say ice hotel, Google that because that should be on your bucket list, FYI. All right, Amanda, number 3. Amanda and her best friend found some money on the road. Nice. They split the money evenly, each getting $24.28. How much money did they find? All right, so let's just start at the beginning where Amanda and her best friend. That means there's 2 people involved, by the way. All right, so they found some money and they're going to split it. If you are splitting money, you're dividing it. You're dividing it by how many people? Amanda and her friends, so that's 2. All together, after they take the money and split it, they have $24.28 each. Now, I know we talked about each means almost always having a variable with it, but in this case, the 24.28 is our total. So you just kind of have to common sense your way through that to see where each is going to be something with a variable or if that's maybe part of your total. All right, so that is our equation. Now remember, I told you earlier when we had a division problem we were setting up or formulating, we could also do division in the form of a fraction. All right. So, now what? Let's solve it. Draw your line. Figure out what kind of problem it is. Well, we've said it like 5 times. It's a division problem, so we need to multiply. Please don't put an X right there for multiplication. Why? Tell them. Somebody tell them. Because that looks like a variable, and you are not in elementary anymore. Don't make such a foolish mistake. Come on, guys. You already knew that. I was just seeing if you were listening. All right, whatever we did to our left side, we do the exact same thing to our right side. That lets us cross out our 2's because these are inverses of each other, and that means they're crossed out. So you're left with M equals 24.28 times 2, which gives us 48.56. Alternate answer would be 48.56 equals M. If you wanted to go back over here, I know some of y'all love cross multiplication more than you love chocolate. So what you could do is just make these both fractions, cross multiply, and you're still going to get the same answer. Number 4, the library charges a fine each day that a book is late. If Ben recently paid a $3.77 fine for a book that was 13 days late, what is the daily fine? All right, so the library charges a fine for each day that a book is late. Do we know how many days late he was, by the way? Do we? Sure do. 13 days late. And for each day, let's just say We'll use F for fine. Now, 13 days times whatever this fine is, 13 times whatever the fine is going to equal his total amount that he had to pay to the library. And we actually know what that was. It tells us right here that that was $3.77. All right, so then you say, I got this, I've been doing this. I know this is a multiplication problem, so I do division. All right, so I'm going to divide by 13 on both sides. Let me write that, forgot that. And your 13s are crossing out because they are inverses of each other. Because look, remember, this was 13 times F, so we had to do division. So the 13s crossed out, but don't forget, only the 13s crossed out. Your F is still there. Your equal sign is still there. And when you divide 3.77 divided by 13, you get 0.29. So that means there was, if we're talking dollars and cents, there was a 29-cent fine. The fine was 29 cents each day. And we know that he had a 13-day, his was 13 days late, so if you say 13 times 0.29, you get his total amount that he owed the library, which was $3.77. All right, you can stop here and go to the agenda on Canvas, or it's written on the dry erase board. The agenda says that after you watch the video and take notes, you are going to go get the one-step equation maze worksheet from your substitute, who is Miss Donald. Or if this is 8A watching this, you'll get the sheet from me. If you are in need of a whole lot extra practice, I'm going to keep the video going. Now again, this is optional at this point. We are 1 hour and 17 minutes in. So that leaves you 15 minutes to work on your worksheet that if you don't finish it in class, it's for homework. And it will be for a formative grade. These are easy one-step equations. This should be easy. Follow the maze. The directions are on the top of the page. Now again, I'm going to keep going with this video for those of you who need extra help and extra practice. Either way, you can keep going or not, but whether you do that worksheet now or for tonight, it is due next class. Okay? All right. I'm going to keep going for those of y'all who want some extra practice. Number 1 says x plus 22 equals 30. This is a one-step equation. It doesn't matter what type of equation it is. Go ahead and just write your line straight down from your equal sign, just to separate your two sides of your equation. All right, what type of problem is this? It is an addition problem, so we need to do the inverse to be able to solve it, which is subtraction. We are subtracting 22 from both sides because just like you have a balance scale, if you subtract 22 from this side, that means this is going to balance, it's not going to be balanced anymore, and this is going to be kind of up in the air. So to keep this balanced, we need to subtract 22 from the other side for peace and harmony in our lives if you have a balance scale or an algebra equation. It's not hard, just memorize the steps. All right. These two things are opposites of each other. If you want to check me because you have forgotten what that is, say 22 minus 22, and you should get a 0 in your calculator. Do you see how we could have written x plus 0 here? We don't need all that extra. Plus 0 means it really doesn't have to be in there. We could have just written x. And 30 minus 22 is just 8. So your answer is x equals 8. Alternate answer is 8 equals x. An alternate answer is not 8x because you have lost your equal sign, which means you have forgotten the fact that this is an equation, and that's just not right. You can't ever drop your equal sign in an equation. Never, 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 never. Or number 2, x minus 15 equals 60. All right, we're going to draw our line through the equal sign. We see that this is a subtraction problem, so let's do the opposite, which is addition. We're adding 15 on both sides. Negative 15 plus 15. If you want to double check me and think, I don't really know where she's getting that, put negative 15 plus 15 in your calculator, and what should you get? 0. That's why this crosses out, because 0, we don't have to write that in our equation anymore. The only thing that is left on the left side is an x. Our equal sign is still there. And if we say 60 plus 15, you should get 75. So x equals 75 is your final answer on that one. Number 3, we've got 3x equals 36. Draw your line. What operation is going on right here? You should know that that is multiplication. So the inverse of that, to be able to solve it, is division. So we are dividing by 3. Whatever I did to the left side, I'm doing the exact same thing to the other, and then I draw a line to just kind of keep everything neat. So I've got 3 divided by 3, which cross out, and I'm left with an x. I'm left with an equal sign, and then I work this side of my equation and clean it up over here, and 36 divided by 3 is 12. That is my final answer there. Get in the habit of putting a circle or a square around your answers, because I think 8th grade teachers might require you to do that, and if you don't, they just count it off. So just get in the habit. It makes your life easier and your teachers' lives easier. It's a requirement, so just do it. All right, next. X over 13 equals 26. Now remember, x over 13 is the same as x divided by 13. Also, you should just know when you see a fraction, that means x is being divided by 13. Fractions mean division. All right, if division is going on in your problem, to solve it, you need to multiply. Notice, I did not write an x right there, because you do not need to be getting that confused with the variable x. So I'm multiplying by 13 on both sides. Whoops, forgot that in the middle. All right, and then I draw a line across. My 13s are gone. So all I have left is an x and an equal sign, and then 26 times 13, is 338. Number 5, 37 plus x equals 7. All right, so we have x on the left side, and we know that this is an addition problem, but even more important than that, the goal is to get the 37 away. We're trying to get x by itself. That 37 has an understood positive sign in front of it. To get rid of an understood positive 37, you would say minus 37. Whatever you just did to the left side of the equation, you must go to the other side and subtract the same amount from the right side of your equation. By knowing that this is an understood positive where you subtracted here, you were able to cancel out your 37s, and you're still left with an x and an equal sign, and then in your calculator, I want you to type 7 minus 37. You should get negative 30, so x equals negative 30. All right, number 6. Negative 7 plus x equals 28. All right, remember, we're trying to get x all by its lonesome, where it likes to be, all by itself. So we've got this negative 7 over here that I need to get rid of, just so x can be by itself. So I'm going to do the inverse, which an inverse of this negative 7 would be a positive 7. Then I'm going to go to the other side of my equation and do exactly the same thing. I'm going to add 7 on the other side. But I thought you said it was a positive 7. Now remember, at this point in your math career, a positive and a plus mean the same thing. One is an operation, one is a sign. All right, your negative 7 and your positive 7 cancel out so that you are left with an X. You're left with an equal sign. And go to your calculator. I keep saying that because people keep making careless mistakes. You'll do all the work right and then just kind of wing it here. Don't wing it. Use your calculator. X equals 35. All right, let me go back. Pause your video there if you need to write down any of your extra steps. And we're going to keep going. All right, more practice. Again, if you feel comfortable enough to stop here and go work on your one-step equation maze worksheet that Miss Donald, your sub, has, or that I have if you're an 8A kid, go get it now and you can start it if you feel comfortable. If not, I'm going to go through 6 more problems and then we'll be done after this. All right, and remember, whether you turn that worksheet in today or next time, it is due for a formative grade. Hopefully that will be a gift to you guys for something pretty easy, because all it is these type of questions. Number 7, we're going to bring down that line through our equal sign, and we see that X has a 58 being added to it. So I need to subtract 58 from it, so X can be all by himself, like an old hermit in a crowd, in a cave by himself. It's where he likes it. He likes to be by himself. Whatever. That's his choice. Subtract 58 from the other side. Our 58's on the left side cross out because they are opposites of each other and they just turn to 0. So we're left with an X. And then you've got negative 30 minus 58. Put that exact thing in your calculator so you will get the correct answer of X equals negative 188. All right, number 8, X minus 44 equals 16. Draw your line. We know that X could be all by itself, but we've got this minus 44 stuck onto it, and we need to get rid of that. So I'm going to add 44, because the adding 44, remember, is called the inverse of the subtracting 44. Then I'm going to go to the other side, and I'm going to add 44 to the right side, so we stay in balance. I have drawn my line across the equation just so I can clean it up, and I'll see what's coming next. What's coming next is that I get rid of those inverses, and I'm left with an X. I'm left with an equal sign, and if I use my calculator to say 16 plus 44, I should get 60, and that is the correct answer. All right, number 9, we've got negative 9x equals 990. I'm going to draw my line, and I need to look and see what operation is going on. So remember, X has a goal of being all by himself. And right now, there is a coefficient of negative 9 stuck onto it. Now remember, if you've got a number right next to a variable and there's no sign in between the number and the variable, that is a multiplication symbol. So if multiplication is going on here, I need to do division to solve this. Now, what is that coefficient that we need to get rid of? It's not just a 9, it is a negative 9. If I forget the negative, then my X still has a negative with it, and we don't need that. So we are dividing by negative 9 on the left side, but also we are dividing by negative 9 on the right side. I can cross out my 9s here, but I'm also making sure to cross out my negatives there. So we are left with an X, we are left with an equal sign, and in your calculator, you are saying 990 divided by negative 9, and I get negative 110. Remember, at this point in your math career, if you told me x was equal to 110, then unfortunately, you get that wrong because that negative sign is so very important. We have worked with it for too long for you to forget it, okay? So make sure you take very good care and be very clean with your work so that you don't lose a negative sign and make a careless mistake. All right, so number 10, we have x over 7 equals negative 12. So there are a couple of different ways you could work this. You could put this negative 12 over 1 and cross multiply. And I'll show you another way you could also write it, because if you see a fraction like x over 7, you know that that is division. So I could say, okay, well, I'm going to do the inverse, which is multiplication, and I'm going to multiply by that thing that's hanging on to x. So I'm multiplying by 7. Oops, forgot to draw my line, sorry. Whatever I just did to the left side, I'm going to go over and do exactly the same thing to the right side. So I'm multiplying by 7 there. Drawing my line. Now my 7s can cross out, and I'm left with an x and an equal negative 12 times 7. So you should get a negative 84, and so your final answer is x equals negative 84. All right, number 11. 234 plus x equals negative 234. We're going to draw a line down the middle. We see our x right here, and we are trying to get it by itself. Now, we know that this 234 is being added to it. And we're trying, especially when you have a number written at the beginning of your problem, it would be helpful, especially till this makes more sense to you guys, just to go ahead and put that positive out in front of it. Just so we know that if we're trying to X this out or cross this out, that we very easily can see that we need to subtract negative 234. Whatever you did to the left side of your equation, do the exact same thing to the right side of your equation. Now, your 234s at the beginning, cross out. You're left with an x and an equal, and then you're going to use your calculator. And the reason I made this problem the way it is because I know that some of you are just going to very absent-mindedly say, they're the same numbers, it's going to be a 0. That's exactly why I wrote it like this, because those of you who are so good at using your calculator, even to double check things that you just know in your heart are true, you're going to do it and you're going to say, nope, that actually equals negative 468. So x equals negative 468 for that answer. All right, our final problem for number 12. Negative 29 plus x equals 55. We're going to divide our equation into two sides, and we find our variable, which is our x, and this negative 29 is being stuck to it. Now, to be able to get rid of it, we need to do the opposite or the inverse of a negative 29. So that means I'm adding 29 to the left side. Whatever I did to the left side, I need to do to the right side. That allows me right here, since those are inverses, I'm going to go ahead and cross those out because that's just equal to 0. My x is still there, my equal sign is still there, and then I use my calculator to say 55 plus 29 is 84. And that is your final answer. All right, so let's see. I don't know what quite our time is, but finish your one-step equations maze for homework, and it will be for a formative grade. If you're finished with it, turn it in. Most likely you'll have to turn it in next class at the beginning of class. Thanks, guys. I know this was a longer video than normal, but hopefully it'll be helpful. If you're lost, pause it, go back to spots that you need to practice on, or start it from the beginning until you get it. Don't go forward until you know how to do a one-step equation. All right, guys. Enjoyed it. See you soon.